Introduction.
Students, look at these numbers. These are the whole numbers. Now look at these numbers. These are the negative numbers. But what do we call a bigger collection of numbers which contains whole numbers and negative numbers? Those numbers are called integers. Come, let's learn more about integers.
Objectives.
At the end of this lesson, you will be able to define integers, write the properties of integers, and write the operations on integers. Students, what do we get if we add two integers? Let us see. Rohan has 6 balls. His friend Sohan has 5 balls. So how many balls are there in total? Yes, 11 balls in total. From this example, we can say that addition of two integers is also an integer. We can see that addition of integers gives integers. So, integers are closed under addition. Look at Reena. She has 5 chocolates. If she gives 3 chocolates to her brother, then how many chocolates are left with Reena? Yes, you're right. She is left with 2 chocolates. In this example, we see that difference of two integers is also an integer. Hence, integers are closed under subtraction. In general, for any two integers a and b, a plus b is an integer. Similarly, if a and b are two integers, then a minus b is also an integer. Let's now move towards another property, that is commutative property. This is a 10 rupee note. If we add one coin of 2 rupees in it, we will get 12 rupees. Now take a coin of 2 rupee and add one note of 10 rupee in it. Again, we will get 12 rupees. Or we can write it as 10 plus 2 is equal to 12. And 2 plus 10 equals 12. In both the cases, we get the same answer. This means the integers can be added in any manner. Hence, addition is commutative for integers. In general, for any two integers a and b, we can say a plus b is equal to b plus a. When we add 0 to any whole number, we get the same whole number. 0 is an additive identity for whole numbers. Similarly, if we add 0 to any integer, we get the same integer. In general, for any integer a plus 0 is equal to a, which equals 0 plus a. We know that multiplication of whole numbers is repeated addition. For example, 2 plus 2 plus 2 is equal to 3 into 2, which equals 6. Similarly, multiplication of integers is also repeated addition. For example, minus 5 plus minus 5 plus minus 5 is equal to 3 into minus 5. Therefore, 3 into minus 5 is equal to minus 15. Let's now find the product of a positive and a negative integer. Firstly, multiply 6 by 4 and then put minus sign before the product obtained. We get minus 24. Similarly, 5 into minus 4 is equal to minus 5 into 4, which equals minus 20. The product of two negative integers is a positive integer. We multiply the two negative integers as whole numbers. In general, for any two positive integers a and b, minus a into minus b is equal to a into b. Look at these examples. In the first example, two negative integers are multiplied. In the second example, three negative integers are multiplied. In the third example, four negative integers are multiplied. And in the fourth example, five negative integers are multiplied. From these products, we observe that the product of two negative integers is a positive integer. The product of three negative integers is a negative integer. The product of four negative integers is a positive integer. We can see that in first and third examples, the number of negative integers that are multiplied are even, 2 and 4 respectively, and the product obtained in 1 and 3 are positive integers. And the number of negative integers that are multiplied in 2 and 4 are odd, and the products obtained in 2 and 4 are negative integers. Hence, we can say that if the number of negative integers in a product is even, then the product is a positive integer. And if the number of negative integers in a product is odd, then the product is a negative integer. The product of two integers is again an integer. For example, minus 20 into minus 5 is equal to 100. Minus 15 into 17 is equal to minus 255. So we can say that integers are closed under multiplication. In general, a into b is an integer for all integers a and b. Now observe this example. We can say that 3 into minus 4 is equal to minus 4 into 3. Therefore, multiplication is commutative for integers. In general, for any two integers a and b, a into b is equal to b into a. The product of a negative integer and 0 is 0. For example, minus 3 into 0 equals 0. 0 into minus 4 equals 0. Minus 5 into 0 is equal to 0. 0 into minus 6 is equal to 0. In general, for any integer a into 0 is equal to 0 into a, which equals 0. When we multiply 1 with any integer, we get the same integer. For example, minus 3 into 1 is equal to minus 3. 1 into 5 is equal to 5. That means 1 is the multiplicative identity for integers. In general, for any integer a, we have a into 1 is equal to 1 into a, which equals a. But when we multiply any integer with minus 1, we get additive inverse of the integer. In these examples, minus 3 has become 3, minus 6 has become 6, 13 has become minus 13, and minus 25 has become 25. The product of three integers does not depend upon the grouping of integers, and this is called the associative property for multiplication of integers. For any three integers a, b, and c, a into b into c is equal to a into b into c. For example, 7 into minus 6 into minus 4 is equal to 7 into minus 6 into minus 4. Now let us move towards the distributive property of multiplication. For any integers a, b, and c, a into b plus c is equal to a into b plus a into c. For example, minus 2 into 3 plus 5 is equal to minus 2 into 3 plus minus 2 into 8. Similarly, for any three integers a, b, and c, a into b minus c is equal to a into b minus a into c. For example, 4 into 3 minus 8 is equal to 4 into 3 minus 4 into 8. We know that division is the inverse operation of multiplication. Since 3 into 5 is equal to 15, so 15 divided by 5 is equal to 3, and 15 divided by 3 is equal to 5. When we divide a negative integer by a positive integer, we divide them as whole numbers and then put a minus sign before the quotient. Thus, we get a negative integer. In general, for any two positive integers a and b, a divided by minus b is equal to minus a divided by b, where b is not equal to 0. When we divide a negative integer by a negative integer, we first divide them as whole numbers and then put a positive sign. In general, for any two integers a and b, minus a divided by minus b is equal to a divided by b, where b is not equal to 0. Division is not commutative for integers. For example, minus 8 divided by minus 4 is not equal to minus 4 divided by minus 8. Any integer divided by 0 is meaningless, and 0 divided by an integer other than 0 is equal to 0. Any integer divided by 1 gives the same integer. For example, minus 8 divided by 1 is equal to minus 8. Minus 11 divided by 1 is equal to minus 11. But if any integer is divided by minus 1, it does not give the same integer. For example, minus 8 divided by minus 1 is equal to 8. 11 divided by minus 1 is equal to minus 11. Summary. Let us summarize what we have learned. Integers are a bigger collection of numbers which is formed by whole numbers and their negatives. If a and b are any integers, then a plus b and a minus b are again integers. If a and b are any integers, then a plus b is equal to b plus a for all integers a and b. If a and b are any integers, then a plus b plus c is equal to a plus b plus c for all integers a, b, and C. Integer 0 is the identity under addition. That is, a plus 0 is equal to 0 plus a, which equals a for any integer a. Product of a positive and a negative integer is a negative integer, whereas the product of two negative integers is a positive integer. Product of even number of negative integers is positive, whereas the product of odd number of negative integers is negative. If a and b are any integers, then a into b is an integer. If a and b are any integers, then a into b is equal to b into a. The integer 1 is the identity under multiplication, that is, 1 into a is equal to a into 1 for any integer a. If a, b and c are any integers, then a into b into c is equal to a into b into c. If a, b and c are any integers, a into b plus c is equal to a into b plus a into c for any three integers a, b and c. When a positive integer is divided by a negative integer, the quotient obtained is a negative integer and vice versa. Division of a negative integer by another negative integer gives a positive integer as quotient. For any integer a, we have a divided by 0 is not defined, and a divided by 1 is equal to a.